In this video, I will introduce oxytocin and do some examples where problems using dimensional analysis. So this will be a dosage calculation, and this is maternity oxide oxytocin. So oxytocin is a uterine stimulant that is used to induce labor as well as control postpartum bleeding. Oxytocin comes in units per milliliter, and it is described in milli units per unit. We would titrate that rate, meaning we would increase or decrease that rate per that order. So go ahead and put this in your notes. 1,000 milliunits, MU, is also 1 unit. So we might have to use that information. Okay, so based on that information, we can start with example one. Okay, example one says patient currently has an LR or lactated ringers running at 125 milliliters per hour. You have an order to hang oxytocin IV PB or IV piggy bag starting at 2 MU per minute. Uh, increase infusion. Increase infusion rate every 30 minutes by 2 MU per minute if there are no signs of fetal distress. Pharmacy sends 10 units oxytocin in 1,000 milliliters NS. Round all answer to the nearest whole number. So there's three parts of this question. So the first part says, what is the initial rate in milliliters per hour? So in part A, what I would do is I would just do this using dimensional analysis. I think that would be a lot easier. So what you got to do is start with what do you start with? You're going to start with the 2 MU per minute. And our goal is to make sure our final units is milliliters per hour. So that's how you know your answer is correct if your final unit is in milliliters per hour. If it's not, you either did something wrong and then you have to like tweak it. So we're just going to start with our given 2 MU per minute. And then I want to, because we want to get milliliters per hour, so I think I'm going to convert it to an hour. So how do I do that? So I'm going to put hours on the bottom and then minutes on the top. So we know that 1 hour is 60 minutes. And then I want if you go back to remember that the one I told you 1,000 milliunits MU is 1 unit. So you can say 1 unit over 1,000 MU. And then we're really close because all we got to do is we have hours on the bottom, the minutes disappears, and the mu cancels. The only thing we have to do is convert this unit into a milliliter. So we know that 10 units is 1,000 milliliters, right? Because 1 unit is 1,000 milliunits. So 10 units is 1,000 milliliters. Okay. And as you can see, let's see, the units disappear. And then on the top, you're left with milliliters. And then on the bottom, you're left with hour. So if you recall multiplying fractions, you multiply across 2 times 60 times 1 times 1,000. So if I put that in the calculator, That's 12,000 on the top. And then if you do the bottom, this isn't one. So what's one times 1,000 times 10? That is 100,000, like 10,000. That would be basically just one, two, three, four zeros, right? One, two, three, four. The zeros cancels, this zeros cancels, this zeros cancel, and then this zeros cancel. So you're left with 12 over 1, or really 12 milliliters per hour. Okay, so that is your answer for part A. So in part A, I did dimensional analysis. I think that's really easier. Uh, sure, you could do the other method, but I'm not. I think I'll just stick with the dimensional analysis for this. Yeah. So question B, part B says, what is the infusion rate in milliliters per hour when the point is receiving 8 MU per minute? So what is the infusion rate in milliliters per hour? So that means you got it, your final answer has to be in milliliters per hour, otherwise, um, it's wrong. So what when the point is receiving 8, okay, so they tell us you start at this point. So that's what we're gonna do dimension analysis again. And then this time they tell you start with MU, 8 MU per minute. So it's going to be 8 MU per minute times, and then let's see, our goal is to get to milliliters per hour. So we could put hours on the bottom and minutes on the top. So we know that 1 hour is 60 minutes. And then we also know that we want to get MU. So we know that based on the table above, we said that 1 unit is 1,000 milliliters. So be careful how you do this. Yeah, so we said that 1 unit is exactly your 1,000 milliunits. So how do we do this? Do we put the milliunits on the top or the units on the top? You're going to put 1 unit on the top and then 1,000 MU. And then we want to get, what do we want? We want MUs. So we got to get rid of the, wait, hold on. So the minutes disappears. Okay, so we want milliliters per hour. So yeah, the minutes disappears. Uh, so you have hours on the top, and then the mu disappears, but we want this unit into a th milliliters. So what do we know about units? We know that 10 units is equal to 1,000 milliliters. So 10 units on the bottom, and then 1,000 milliliters on the top. Right? Because you want to get rid of the units. That's why I put units on the bottom, and you want milliliters on the top. So that's why you have to know what goes up and what goes down, right? So the units disappears. The milliliters is on the top, which is what we want. So milliliters on the top, and then what's on the bottom? The hour. Then when multiplying fraction, you multiply across, not crisscross. So 8 times 60 times 1 times 1,000 is 48,000. And then on the bottom, 1 times 1 times 1,000 times 10 is Four, four zeros, milliliters per hour, and the zeros disappears. So you're left with 48 milliliters per hour. Okay, let's do part C, the last part. So part C says if the pump is set to 30 milliliters per hour, how many MU per minute of oxytocin is the patient receiving at that time? So I'm just going to do dimensional analysis. And they tell us to start with 30 milliliters per hour. So that's what I'm going to do. And what is my goal? My goal is if the pump set, how many our goal is to get MU per minute. So let's first get rid of this hour by turning it into a minute. So how do I do that? I'm going to put hours on the top. So we know that 1 hour is exactly 60 minutes. And so what happens is the hours disappears, and then you're left with minutes on the bottom, and then milliliters. So you're left with milliliters, but we want that MU. So you need to use your conversion factor. So we know that 1 unit is equal to 1,000 MU. So it would be 1 unit on the top and 1,000 MU on the bottom. And then let's see. So you're going to put 1,000 on the top. Now we want to, so what happens is, hold on, messed up. I was looking at the wrong, sorry. I was looking at the wrong question. So I'm gonna erase. Okay, so we have 30 milliliters per hour, and then we know that 1 hour is 60 minutes. Our goal is to get MU per minute. And what we got to do is we know that, yeah, so what do we know? We know that 1 unit is 1,000 MU, and we also know that 10 units is 1,000 milliliters. So we have to be careful how we do this. So I'm going to start with the 10 units equals 1,000 milliliters. So I want to get rid of the milliliters. So I'm going to put milliliters on the bottom. And then we have units on the top. So we said that 1,000 milliliters is exactly 10 units. And then our goal is to get MU per minute. So we said that 1 unit equals 1,000 MU. So I'm going to put 1,000 MU on the top and then 1 unit on the bottom. Okay, as you can see carefully, the unit, what happens to our units? Let's see, the milliliters disappears. Uh, the minute stays fine. The units disappears, so you're left with MU on the top and minutes on the bottom. So that's how you know it's correct. And then you just multiply across, not crisscross. So 30 times 1 times 10 times 1,000 is 30,000. 1, 2, 3, 4, 5. And then on the bottom, it's on the 1 times 60 times 1,000 times 1, 60,000. And what happens is uh, some of these zeros cancels out. 30 divided by 6 is exactly 5. So you're left with 5 MU per minute. And our units are correct, right? We want MU per minutes. And that's it. Good. Okay, I'm going to stop here.